Hello, welcome along. This is an introduction to writing smart contracts on blockchain. Just want to call out that it's a beginner session, it's a 101 session, so we're going to begin by giving you a very quick overview of what blockchain is. Who knows what blockchain is here? Quick raise of hands. Who's completely fresh to blockchain? Cool, so we've got a few new folk in there, and we've got people who are a bit more skilled. So we're going to go through that really rapidly at the beginning, and then we're going to get into Toolchains, tools to use when you're developing and writing smart contracts. First off, my name is Tom Davies. I'm a senior manager over at Cisco DevNet.
My name is Valor, and I'm Tom's bodyguard, so I'll be standing like here the whole presentation.
Really bad.
But I'm actually part of Cisco. I do a lot of research, and blockchain is some of the things that we're focused on. With my teammate Sana down here, we just do experiments.
And good ones at that.
Yes, we have fun.
We're part of DevNet over at Cisco, so we're focused on our developer advocacy and everything to do with how you would integrate and interact with our solutions and open source in a Cisco kind of community. We focus on that. We're very much developer focused. We have nearly 500,000 folks in our little community now. Hopefully some of you guys will join that community too. And you'll get access to all this stuff completely free, from learning labs to learn how to code and use things like blockchain, and also like be able to spin your own blockchains up, to things like Sandbox, which give you development environments on demand completely free, and we'll spin them up for you so you can play with things like OpenFAS, serverless architectures, blockchain, any of the Cisco technologies out there you can get hands on immediately. We do events, support, and we even do code exchange now, where our community can write code and then give it us back for the rest of the community to use. So if you do feel like you want to, join us over at developer.cisco.com, takes 2 seconds, sign up, and you get all that access totally free.
So let's talk about what we're going to talk about today. It's really just 3 parts. In the first part, we're gonna go over some of the fundamentals of blockchain. We're actually gonna go over the technical parts of it. And then after that, we're gonna show you our development environment, the different tools that we use. And then the last part, we're hoping that we'll get some audience participation. So if you have your laptops, you can open up, and hopefully you can buy some of our cryptocurrency that we're gonna mint for you here today, and when we do our fun ICO.
When we become millionaires,
yes.
And then you help us. We're going to start off, though, with some blockchain fundamentals. So just to get it on a level playing field, we're going to go for 10 minutes of explaining blockchain, which in 10 minutes can be quite difficult, but we'll give it a shot. So let's start. What is a blockchain? So as you probably know, actually, blockchain is just a database, a transactional database. Difference between a blockchain database and other databases is when you want to participate in a blockchain, you all have to download a copy of that entire database. So if we were all in one blockchain, we'd all download that complete blockchain code and all the transactions within it, and then we can transact in it too. We can join in once we have a copy of that blockchain. No one entity controls it. So it's not like one entity just have all that data and then you transact into it. It's not like Facebook, for example. It's much more that because you all have one version of it, we all transact into it, we all update that same database across all of us, and it ripples through everyone, so everybody's updating has the same transactions within their database. And it's cryptographically secure, as I'm sure a lot of you know, so it's a trustless system. So I can transact into that system and not have to trust any of you, and still know that not only my transactions are valid, but all your guys' transactions are valid as well, and you can't double spend, you can't try and abuse the system because of the cryptographically secure mechanisms around it. I won't go into too much detail on those. We've got a few slides on it later on. Now, the fundamental things at the bottom here, transactions. Everybody transacts on the blockchain. A transaction could be a change of money, it could be a change of asset like a document, it could be a change of ownership of anything like you now own a car. That transaction gets put into a block, and then those blocks get put into a chain. Blockchain. Amazing. And that's the general high-level view of what a blockchain is. So I talked very quickly about what putting transactions into the blockchain. What is a transaction? So the easiest way to think of a transaction, the quickest example that you can come up with is buying a cup of coffee at a shop. So Alice wants to buy a cup of coffee from a coffee shop. To do that, are using Bitcoin, for example, they need to create an account on the blockchain. So anybody can sign up to use an account, create an account. And what happens when somebody signs up is you get a public key created that gets exposed to everybody on the blockchain. Everybody can see that public key. Then you get a private key that you keep to yourself. You never want to give that private key out. If you give that private key out, other people can drain your accounts of all your lovely crypto money. Don't be doing that. Keep that to yourself. So you got a public key and a private key. And when Alice wants to go and buy a cup of coffee, she pays by sending the money to the public key of the coffee shop. The coffee shop also has an account. That also has a public key and a private key. So when you send money to the coffee shop, you use its public key and say, I want to send money to the public key. Alice then signs it with her private key, and that means that transaction is then valid.
How many of you have actually bought or transacted something on the blockchain by buying something or just by raise of hand doing a purchase? A good amount of you here. So there's several different cryptocurrencies that you can use to do this, and you can buy it. You can use cryptocurrencies for more than just holding them and hoping they increase in value.
Though they do. And we'll get onto that in a short while. So that's a basic transaction. And once that transaction's into the blockchain, it then gets transmitted to all of the blockchain and everybody else within that blockchain. So everybody gets to see every transaction that was ever committed to that blockchain. So you can see every transaction since year dot, since it was first, Genesis effectively, since it was created. Here's a look at a block. A block essentially is just a whole bunch of cryptographic information, but if you were to decipher it, you'd have Alice's account, the coffee shop's account, and the money that was getting transferred in this trivial case for this easiest transaction that we can describe quickly.
So the people that actually put those blocks together are certain actors that live on the network, and they're called miners. How many of you guys are running a miner, a Bitcoin miner or Ethereum miners? A couple of you guys in here. Very cool. I counted about 4 people. So these miners, what they're doing is a lot of them today, for the popular cryptocurrencies that you've probably heard of, like Bitcoin and Ethereum, you typically have to use special hardware to do that. So one is, Bitcoin, for example, there's a popular miner called the Antminer S9 that a lot of people are using to do this. And when you mine these transactions, you're basically trying to solve a proof of work that we'll talk about in the next slide. But these miners are all on the network, and they're taking all the transactions, and they're the ones that actually make sure that there can't be any double spending, because anytime somebody spends, the miner is going through and looking through the previous spending records or the unspent transaction outputs to make sure that nobody has actually spent that money before, and then they put it in a block. And that block is immutable. And if that block is actually accepted by the larger community, then that becomes the basis of the chain of blocks. Blocks in different cryptocurrencies are created every couple minutes. In Bitcoin, for example, it's about every 10 minutes one is created. One of the things about mining is that with Bitcoin and some of these other currencies, there's only one clear winner. And so expending a lot of hashing power to try to create the block is sometimes a futile effort. And because of that, a lot of these people will actually join a mining pool. And what a mining pool does is it says, okay, we have about 100 of us right here. We all have our different Bitcoin miners. And if any one of us wins, if we come up with a proof of work first and that block gets accepted by the peer-to-peer network, then we will split that the winnings of that, or the newly minted Bitcoins and the transactions. What's the word for tip?
The tip.
Yeah, I was thinking.
You mean like gas?
Yeah, no. So they'll actually get the. They'll actually get that, and they pull that and divide it among the people who, among the hashing power. So
the reward, effectively.
The reward, yeah. So that's some of the reasons you'd want to join a mining pool. So here's what a proof of work is like, and you notice actually in the original Bitcoin paper it never talks about blockchain. The word blockchain is not even in there, but it does a great deal of talking about what a proof of work is. A lot of different cryptocurrencies have different methods of how they're going to verify what's going to be accepted as the next block. But in Bitcoin, it's proof of work, and so you actually have to do some mathematics to make it work. And one of the properties that it uses is called a one-way function. So you guys all remember from algebra, if I, y equals x squared, if I say y equals 4, you know that x is going to equal 2 or negative 2. Like, you can figure out that answer. What a one-way function does is it says that it's very difficult if I give you y to know what x was. And in fact, given the computing power that you might have, it might take you 1,000,000 years to actually come up with what x was, because the only way you can figure it out is through brute force. And so one of these algorithms that they use, the elliptical curve algorithm, requires that it takes a lot of computing power to actually find the answer, or to solve x if you know y. But if somebody gives you x, you can verify very quickly that it equals y. And so that's what we're trying to do with proof of work. What we do is we take all those transactions that Tom showed you, we bundle them all up, and then we do a hash of those transactions. And we put that into a header. And then we take the date, we take the previous block, and we put that all into one header and then in a hash. And then we have this one part that we can change, and that's called the nonce. The nonce is the one piece of that header that we can change. And what's not, and so what we do is we just run this through our algorithm trying to change the nonce, and we're trying to come up with a hash number that has a number of zeros in front of it. So currently I think it's about 17 or 18 zeros is the number that has to come out of this hashing algorithm. So it's very difficult to come up with, but once you know it, anybody can verify that it was the right one.
Really quickly, yeah.
That's what we're trying to solve with proof of work. So in the mining pool, what we do is we divide up among all the different people, and they're just all flipping nonces. They're just changing the nonces to come up with the right one, and that's how we actually do proof of work. What's nice about this is if anything changes previously, it changes the entire chain. And so the chain is immutable, nothing can change. Even if you change something like way back when, the complete hashing of any of the subsequent blocks would be completely changed. That's how we make it immutable and tamper resistant. So once we have the block, we know it's right, we broadcast it through all the rest of the network. If it's accepted, then we get to have those, the new Bitcoins that were created or whatever the algorithm says. We do this about every 10 minutes, Bitcoin does it. Bitcoin is very interesting because there's about 21 million coins that will ever be created, and over half of them have already been created.
Yep.
And so, and this works really well. A lot of times different miners will come up, they'll have the block to say, this is the next block, and somebody else will say, no, I found the next block, and they'll look completely different. And what Bitcoin has is this idea of eventual consensus, and what that means is that as one block, as more and more blocks get put on top of one block, which may be chosen by half of the nodes in the other one, then that one that has the longest history becomes the standard chain, and the other one is eventually dropped. So that's what eventual consensus means. So, and that's blockchain. The block refers to the previous block. Another way of how we have that from.
Now, we just talked about blockchain as if it's just one thing. There are actually a lot of blockchains out there. So the Bitcoin blockchain is a famous one that everybody knows, and that uses an implementation of a blockchain. But there are lots more. The one that we're going to focus on today is actually called Ethereum. Ethereum is another public blockchain that any one of us can join. And the reason why we're going to focus on it today is because it allows Turing-complete code, i.e. code we all write, to be deployed onto the blockchain and have its own little account too. And then you can call that code and execute it. They're called smart contracts. Now, as you probably know, it's the worst naming convention in the world because they're not smart and they're not actually contracts. They're just code. It's just logic that you write and then put into the blockchain that then can be executed as part of any other transaction. When Ethereum was released, which was about, I want to say 3 years ago.
Yeah.
It was such a dark art to try and code on it. There was no tools, there was no help, there's some basic documentation, but it was really quite difficult. But that community has come on leaps and bounds since, and this is what we're going to go through today. We're going to talk about the Ethereum ecosystem of tools and tool chains because it's something you can all take part in too, because it's a public blockchain and the code is completely all open source.
It just has a lot of developer tools to it already. There's other ones that we could have chosen, but this one seems pretty good.
There is, yeah. There's literally lots of blockchains there, and they all have their own tool sets that are obviously being built. The smart contracts themselves, so just code on the blockchain. There are types of triggers to call smart contracts. You can explicitly call it. You can wait for a date function, say on Christmas Day, you all get paid 100 Bitcoin. Yay! Or you can do it on a time thing, like over a period of time, we will release this many coins, and it will execute itself. Smart contracts can also call other smart contracts, so you can actually cause a clash of different smart contracts calling different, like a waterfall effect through.
And this is why sometimes you hear a lot about blockchain with IoT together, because the different devices
talking to different devices.
Each other.
Yeah, exactly. It's marriage made in heaven. Now you can think of the smart contracts then as like stored procedures. For anybody familiar with Oracle here, you used to have SQL procedures stored on the database, and it's kind of the same thing. You put it down onto the database, and then you can call it. There are massive problems with how these are coded, though. Right now, it's kind of like the Wild West. There's no real best practices for coding smart contracts, and they're only being formed now. So if you create a piece of code, you deploy it to the blockchain, and it's to gather some money up. If you don't code it right, then there might be a loophole in there that means somebody can filter that money out. And that's exactly what happened in the DAO kind of example. And that drained a whole bunch of money, like millions, out of the contract before they could do anything about it. And they had to hard fork Ethereum to make up for it, which is a bad thing.
That's why you see Ethereum and Ethereum Classic now. Because of the DAO.
Yeah, because of the hard forking had to split the base. Because of that, is consultancies building up around smart contracts, and the best practices are being formed. And the tooling is rapidly developing, as we've talked about. The great thing is, though, anybody can create their own tokens. Anybody can create their own currency, should they wish. Anybody can build what they want on such an open platform, because it's just Turing-complete code. And that's what we're going to do today. We're going to make our own tokens and build our own currency, which obviously then you guys are going to buy, and we're going to become millionaires. So that's awesome. Thank you. A quick note on how you would build an application on blockchain. So if you think of a blockchain as a database layer, and then you think of the smart contract as a code layer, then if you have a user interface at the front here, you call the blockchain to execute your code. And therefore, because you're actually executing transactions and mining transactions and validating transactions, you guys, if you were the same part of the blockchain as me, if we were all on Ethereum, are actually executing my code for me using your compute power. So then, as long as that blockchain stays alive, I've got an indestructible application that will never die, because my code is always out there, immutable. Quick note on blockchain types, to just finish this overview off. There are two types of blockchains generally, non-permissioned and permissioned. The non-permissioned is what we're focusing on today, things like Ethereum, where anybody can join it, you don't need permissions to do it. But there are also permissioned ones. These come in private and community. A private is where one company might just deploy blockchain for things like cross-departmental transfers that they want to log, or you might have a community which is maybe 5 to 10 banks working together. They don't want to see the whole public eye see every single transaction, what's going through those banks, so they just have 5 to 10 that might work together, for example. They're the different types of blockchains that we have. Okay then, so that was a fairly quick overview of blockchain. Hopefully that's level set you guys. Now we get to the fun stuff of creating our first contract, creating our tokens.
I'm kind of sad we didn't get to go over all the drama of what's happened over the last couple of years in the news, the headlines, finding Satoshi, and all the fun stuff that you guys
had to
probably
put
been
all that out, I'm afraid. But we do get to create our first contract, and I do get to be a millionaire, so it's not all lost, don't worry. We're going to talk about tools and tool chains now in this next piece, and then creating our first contract, and then how you can get involved in a few experiments with your own contracts and actually buying some of the tokens that we create just to see how you would do it. So what we're going to do is create our own token, and it's going to be the DevNet ICO. The ICO is an initial coin offering, basically. It's a way that companies do A-round funding in the crypto world, effectively. If I want to get some money off crowdfunder, basically, and then I will offer you something back for that token should you buy something from me. We're going to create our DevNet coin.
And we're going to offer you, in turn, our blessing.
Yeah, to buy some.
That's what we're giving back, right?
Well, we don't expect any money off it.
Yeah, okay.
So we're going to create our own token. This is how it's going to work. This is what we're going to build in our contract. And then you'll see the code for this in a minute. And this is what it's going to do. So the contract itself will create 20 million tokens. The contract is going to be of an ER20 standard. So that's a standard that's been formed on Ethereum, for example, for writing contracts that has to offer certain functions and procedures to be ERC 20 compliant. And there'll be things like, give me the value of what's left in that contract. Give me the balance, for example. And there's a few others which we'll show you in a minute, actually, in the code. When that contract executes, not only will it create that 20 million tokens, but immediately Val gets 5 million and I get 5 million, which is quite nice. Yeah.
It's just the way we decided to do it. We figured we should give ourselves some money for it.
Yeah, then we get loaded.
Why not?
And then you guys, there's 10 million out there for you guys to buy like really quickly.
On
and
the
I'm
market.
expecting you to crack your laptops open and buy them in seconds, obviously. Now, does this sound like a good ICO to you guys? Yes, if you're me and Val. I'll probably stop there.
Don't worry. We're going to show you how to buy fake money with fake money, so you don't have to actually spend
Everything we're going to show you is using fake money on a test network, so we don't actually want you to buy anything real.
Yeah.
The standard there is the URL at the bottom. You can hit that. You can see this for yourself. No problem. It's all open. Here's the type of tools that we're going to use in our tool chains for writing that contract and then deploying it onto the blockchain. This tends to be about 3 different steps, give or take, in writing a contract. They'll be writing it, they'll be deploying it, and then there's the platform. Where are you going to deploy it to? The first one is writing a contract. So what would you use to write a contract? There tends to be, you can either go command line, so you can just go like completely down to like Vim and Atom or whatever your text editor of choice is, or you can use things like Remix and Parity. Remix is an in-browser based IDE, effectively, for writing smart contracts, and that will also do things like compile it for you and allow you to deploy it. And then we have things like Parity, which is an offline IDE, which is a bit more tricky to use, I would say, and you have to have connectivity to the outside world and connect to your blockchain. It's a bit more hands-on.
Anybody been using Parity at all? A couple of people?
Oh, it's Parity. I know.
Yeah, okay.
Have you used Remix? Which one do you prefer? Remix, there we go. Okay, good.
Yeah, we were a
My
little
boat as
bit,
well.
we weren't, when we did Parity, we had it tried to be a little bit more thick than we liked.
Yes. Yeah, I definitely prefer the
If the
Remix
Parity
boat.
guys in here, we loved your stuff.
Yeah. Yeah. Then there's like deployment options too. So you could deploy using like something like Truffle. I like Truffle a lot. That's basically a command line deployment tool, and we'll show you that actually in what we're going to show you today. And then there's things like MyEtherWallet and MetaMask. You get a good photo? Sorry, I had my hand in the way. And we had MetaMask and MyEtherWallet too. And these are more, like MetaMask is brilliant. It will stop you getting things like phished. My God, there are a lot of phishing sites out there when you get into this world. And MetaMask will be something that you download onto, say, your Chrome browser and will protect you from going to any phishing sites. And so you don't put your private key in somewhere where you don't want it to go. It's also great for creating accounts. And actually looking at your blockchains too, and what happens inside them. MyEtherWallet is brilliant too. That's gives really good documentation on how to be safe when using blockchains and contracts, and how, again, not to get fleeced, and what to do and how to store stuff. So if you want to get started, that's a brilliant tool and a brilliant website to go and hit.
Yeah, it's quite interesting that you can actually get started developing, and the only thing you actually need is your browser. You can do all the development inside of a web browser. So
it's true. I mean, Remix as well bleeds into deployment because that will allow you to deploy your smart contracts too. And then the final one is platform. So you need somewhere to deploy your smart contract. And sometimes you don't want to just go straight to production. We're all developers. Last thing we want to do is chuck our code straight into production. So there are also test networks, things like what we see here, Kovan. There's another one called Rinksby, for example. And these are exact stage environments of Ethereum, except for the money behind them is fake. You can just request the money from a certain place, we'll show you, and they'll give you fake money. And then you can use that on your transactions, rather than going to Ethereum and paying lots to have a contract deployed there that might not work. So we'll use that today. Now, so they're kind of some of the tools that we can use, and this is how you would build them into a tool chain that you might consider. So the first one is a user interface based, so like the web browser that Val just touched on there. And you can do things like use Remix as an IDE, and then you would write that, write your contract in Remix, and then you could deploy it using something like MetaMask. You could also use Remix, to be fair, but if you might want to use MetaMask to deploy it too. And then we want to deploy it somewhere. We're going to use the Kovan test network so you guys can buy tokens and create contracts yourself without spending actual real money. And then you could also use something like the command line version, which is like Atom. I think Val's going to do the demo today. And this is going to be, Val's a bit of a Vim fanboy. So Val's going to be on Vim, old school. And then we're going to use Truffle as a text editor, and then Truffle as a deployer, command line. And then we're going to go to Kovan as a test network.
Great. So let's start looking at Solidity. So when you first start programming on Ethereum, you can use a couple of different languages. The one that seems to be the standard one that is caught on is Solidity. And Solidity looks a lot like JavaScript, but it's strongly typed. And let's go ahead and look at the code that we've created with the DevNet code. So Tom mentioned an ERC20 compliant contract. That's what we did ours based off of. So I used Truffle to create this new environment. Just did Truffle init, and it showed up. And then I actually used Remix when I was writing the contract initially, because what's nice about Remix is that it compiles it for you. Remix is just in the browser. So I kind of use a little bit of both. So this is Remix. You just go to remix.ethereum.org, and you can select your compiler version over in settings, and you can put the code in there. So that was like a nice way to actually go about just starting it, because it does the syntax checking for you, and it compiles it for you as you get started. So let me show you the basic outline of this environment is, let's see. Oh, I guess that wasn't the right command to do, was it? So there's basically there's the contracts where you actually write your contracts. There's migrations, which have the scripts that deploy your contract to your different networks. There's the test where you would put some of your testing, your assertions to make sure that the contract works the way you think it should work. And then there's this Truffle.js file. So let me first just show you the contract that we wrote. And this is called DevNet coin. So there's also this idea of a migrations that Truffle puts in there. It actually makes your migrations a smart contract. So as you go through and deploy new versions of your previous contracts, if you wanted to, then the migration is actually a smart contract itself. So here's the smart contract. We actually imported a lot of this safe math just because of the way the blockchain works. There's a lot of pitfalls where somebody can go through and take away all this hard-earned cryptocurrency that we're about to generate. This is the interface. This is what needs to be defined, the ERC20 interface, for something that is going to be ERC20 compliant. It has to have these functions in here. Like you have to say, what's the total supply? You should be able to get the balance of the different people. And here you can see I'm using inheritance. I have DevNet coin, and we say that it is an ERC20 interface. And then most contracts will have a constructor. And the constructor is basically just saying, okay, I'm gonna take Val is this address, and then Tom is this address. Put that in when you initialize this, and then give us 1/4 of the money supply each. So we'll have 5 million each, and then do the transfer of the funds into our account. And that's how you get the tokens in. It's very simple to do that. And then there's a couple of other things, some of the best practices. You don't actually just give money to somebody. Instead, you let it so that they can actually withdraw. And the reason for that is because that's subsequent. You can get hacked that way if you just transfer to them. And then the last thing is we want to make it so that anybody can buy it. So we have this buy dev, which by putting the payable there, that means that it can accept Ether. And that gets through, and then we'll transfer the money to them.
Ether is the monetary value on Ethereum. If you didn't know, it's like Bitcoin for Ethereum world.
Thank you. And then there's also this idea of a function that has no name. And this is the default function. So if somebody just sends you money, what are you going to do with it, right? And in that case, we're just going to buy DevNet. So that is the code. Briefly.
So, yeah, very briefly. So what we would have done there is use a text editor to write a contract, and then we need to deploy it. So we've done the first couple of steps. Now we're going to show you Truffle and how to actually deploy it onto a blockchain. As soon as we deploy this, we become millionaires.
It's so easy.
197 lines of code will make you a token millionaire. You got to love blockchain.
So the way we do it in Truffle is we do truffle migrate, and then we call out the name of the different network that we're going to do it on it. I have my networks here, so you can see that I have the Covan network, the main network, a development network, and so I've started a development environment right here, but I can also do it on the main one as well. So I just do truffle migrate, and it's going to look in those different parts. And I'm going to say network, and in this case, I'll just say development. So that way it's just doing everything on my laptop. I don't have to download a development. I don't have to be attached to the main blockchain, and I can start running some tests on this to make sure that it actually works. Then after I'm done, if I like it, then I can put it to a test network, like the Covan network, and this will just go through and push it on there.
And that's basically like deploying it to stage where more users can access your contractor core, start playing with it, try and get money out of it, put money into it, see what happens, make sure it's user ready.
Right. So now this will get deployed on the Covan network so that we can actually look at it here in a second.
So that's busily deploying. That takes probably like 30 seconds a minute to deploy. Why we use a test network, I think we've discussed this anyway, but it's really so you don't have to spend a lot of money on the real Ethereum network. And you can use the test network where there's not real currency associated with it. So we can go to the Covan faucet, it's called, which is like a Slack channel, effectively. You put in your public key, and it'll give you the money back. It'll give you 5 KEF every day that you can spend. You can do a lot of transactions with 5 KEF. So that's why we use it. Once we deployed that contract, what's just happened there is we've used Truffle to deploy it. It's automatically created our funds, created 20 million tokens. It's transferred 5 million each to us. I'm a millionaire. And then it's actually sent the contract ID back to us so we know the public ID of that contract so now anybody else can call it. That's all well and good, but you've only got my proof for that. You saw us do one Truffle line of code to do all that work because we've set up this chain already. So how do you know what's actually going on in your blockchain? How do you see what's going on in your blockchain? And that's through observability tools. And these are a couple of ways that will help your observability. One is MetaMask, and you can use MetaMask to look at your accounts and then click on Etherscan, and Etherscan will then bring up what's happening inside that network. If you go to covan.etherscan.io, it will go to the Covan site. If you just go to Etherscan, it will take you to the real Ethereum network. And we'll see that now so you can show inside the blockchain. Oh, sorry, my friend.
So the one that we just deployed right here showed that the DevNet coin was created right here. So I can go to this one right here. I can just copy that contract address, and then I can go into here into the Covan, and we'll update it. This was my previous one. And so notice here that I'm on the Covan network. If I was on the regular Ethereum network, this wouldn't show up. And I can go through and I can see the actual the transaction of what happened. And now if I want to, I can go look at the actual token of it, and you'll be able to see the transfers of it. And you can see that it'll actually have given some to me and some to Tom. So this address, which is Tom, he got 5 million, and this one is mine. I got 5 million as well. So there's a lot you can actually look into here more to see some other things as well.
And the great thing is you can now, there's 10 million out there for you to buy, and you can now go to devnetcoin.com and see the instructions for how to buy them. So show me how to get some. I'll let you do it. I'll let you go for it.
So just go to this. You can just go to our website that we created, devnetcoin.com. We've made it the instructions so that if you want to just get some free Covan Ethereum, you can get that, and then you can start testing with it, and you can buy, and you can say, has anybody bought anything on when you come to a next talk and it says anybody bought anything with Ether with a cryptocurrency, you can say yes, I bought some DevNet coin. So and then your address will be placed up here. You can see that we have some errors in our code. We have some not a number. Somebody tried to not give us some Ethernet but we'd love it if you guys tried to hack this as well. So not the site, please, but the contract. So. That's the DevNet coin.
And those instructions there will guide you through what you need to download, what tools, and take you step by step through that so you can actually buy some, should you wish. So if you want to continue your learning, there's 2 things you can do. hit those instructions, buy some DevNet coin, get a feel for how transactions on the blockchain work, get your first account up and running if you don't have one, read things like MetaMask and MyInfoWallet to understand the pitfalls and how to avoid them, and then start downloading these free tools that we've shown you in these Toolchains to actually start writing your own first contract, create your own first token, have a play, see how it goes. Really do encourage you to just start developing on a blockchain. And if you want, you can also hit DevNet Sandbox, and that'll give you, we have a Hyperledger Sandbox there, which is an open source effort from the Linux Foundation, and that will spin you up a blockchain ready for you to use, a private blockchain, almost like a development blockchain, and we'll do that for you in minutes. And at that point, then we'll give you the cred so you can hit your blockchain and start developing on the Linux Hyperledger project type blockchain. From there, we hope you have fun learning about blockchain and blockchain development. It's been a pleasure to chat to you. Thank you very much.
Yeah, thank you. Yeah, good to keep that up. Oh,
do we do questions? Is there any questions? Three minutes.
Yeah, we talked.
You didn't mention anything about gas or gas price. I mean, I don't know much about it, so I'd like to know. I have created my own contract, and how shall I explain? Because to mine every contract, I need to pay some gas price, right? You able to hear me?
I can hear you. Yeah.
Okay. So we need to pay some gas price to mine that contract.
Yes.
So how is that decided? Like
the gas price for the contract, a lot of it has to do with how big the contract is and how much it actually costs. So like if you have a lot of code in there, then it's going to cost a lot more gas. So the more concise you can keep the code, the lower the gas price will be when you're doing it.
Okay, so it is already fixed for each block. Like for example, we use if-else blocks or for loops and all those things.
Yeah, that's gonna.
It is already
gas
kind of fixed.
Fast.
Okay.
Yeah, so that's gonna make it go way up. In fact, there was a token, a lottery almost that came out I think earlier this year, which was Ethereum sweepstakes, where you could win like $4 billion or something like that, and the contract code to execute it, you had to actually set the gas even higher than the standard one that a lot of contracts will go through with, because the code was so long.
Okay.
So,
yeah.
Thanks for the question.
Yeah, thanks.
Yes, sir. Oh.
So thanks, guys. Nice stuff. I think you just made my own talk pretty much easier. So I think you should also mention something about programmatic tools for deployment, like Web3.py or Web3.js.
Oh, that's so true. Yeah, we missed a lot of the things like Web3, where you can actually, and I think that is the recommended way to get going, is to actually create like a web page. The DevNet coin one, that's a React page that we wrote that actually has a Web3 on the back end that's communicating, in this case, with the Covan network, because it's on a test network. But yeah, anything else you wanted to say?
No, nothing, just suggestion.
Yeah, thank you. No, I appreciate that. It's so hard because you don't know like what the
level?
different things you can do. So what you can go over. So thanks for the feedback, sir.
Yeah. So one of the things you mentioned was that the elimination of trust is one of the things blockchain does, right? How does that work when you have a trust holder, like a big corporation, because the permission-based ones are also a thing, that doesn't really want to give away that trust? What's the incentive there for the trust holder to be participating in the blockchain?
I'll take this back out so I don't hear myself speak. Really weird. I would say, so this is for permissioned blockchains, I guess, with a trust holder. It's counterintuitive, because the idea of blockchain is it's completely open and completely decentralized. So with the permissioned, you really do have to trust the users within that. It's not completely trustless. You have to trust the other parties within your organization or within your community. It's not as open as, say, a public blockchain, where you literally don't have to trust anybody. There has to be some element of trust once you start permissioning people to actually enter, and who mines and who doesn't mine. There has to be, you break that model slightly, in my opinion.
you start seeing like these hybrid things where it's like partly open and partly closed. Have you seen other ways to solve that, or?
Well, not necessarily, but there's a lot of hype, of course.
Of course, yeah.
And one of the things I see as a big issue is that there's huge interest in some people to keep holding the trust.
Right.
So then the public blockchains, sometimes they want to do amazing things, and I think they want to do very good things. But then the way the incentives are aligned, that's just not going to happen within the next 10, 15 years.
Yeah, I completely, and you know, as we look at it too, as a corporation like Cisco, it's like, okay, well, how can we adopt blockchain technology? Well, the whole idea of blockchain is to keep it open and get rid of the middlemen, right? And make it so it's a community of people. And so how does like a single corporation try to retain control yet be open like that? And I'm not sure that that's been answered, right? Because I mean, there's a lot of things out there, but I don't know of anything that's really like caught on like people like this is the way, right? But it'll be interesting to see how it evolves. Maybe you'll have the idea.
I hope so.
And you'll be telling me because I don't.
Yeah, and that's the problem with the public as well. Like the speed of transaction.
Any more questions?
Oh, well, you can't hear me talk. Never mind, go for it.
Hi. How can you prevent or deal with illegal content in the smart contracts? Like if somebody writes code that DDoSes some server.
I'll take this out again.
You want
So there are things in place to stop people, say on Ethereum, for example, to stop people writing. You could even write just ridiculous code. I put an infinite loop in there and it just spins around forever, executing. There's a gas price associated with everything that you do. So when you put a transaction in with code on, you have to provide some gas, some money, a very small amount of like money token to actually pay for that execution of that code. If at any point that gas price runs out, then the code stops executing, everything gets rolled back immediately. So you have to have enough in your account to actually pay for a DDoS attack.
But related to that, like, okay, what about like ethical things? Like, what if people are doing bad things? Like, let's say like somebody starts a hitman service and he wants to hire murderers or something like that. Like, how can that be stopped? I don't know, the community maybe, but the whole idea of these public blockchains is that they're censor resistant, right? And so I don't know. What do you have any thoughts on that?
Actually, no. But I was afraid that if some illegal stuff gets into it, that it actually might make the whole coin. Yeah.
Well, remember that's what happened to Bitcoin initially, right? Like, who were the first people that were using it, like Silk Road and things like that. So it got this really bad rap, and it took like 5 years later before everything went crazy, like it did in November, December.
Yeah, but if you put a picture in it, this byte array,
Ah.
that is illegal, and it's immutable, so you can't remove it.
Yeah.
And everybody will be spreading that content.
Yeah, but think about how, well, I guess it depends on the chain, but like, think about like Bitcoin, like there's only a megabyte that you can put in. And so I guess you could decentralize the image and stuff. So you're right, things could happen.
Yeah,
I don't
There's
really
nothing
have a good
stopping
answer.
that is a valid use case of abuse of
Yeah.
blockchain.
And then we have a problem.
Yeah.
There are many problems with blockchain. That's
But,
true. It's not perfect.
You know, let's not let the 0.3% ruin our fun. Or, you know?
Yeah. Yeah.
All right. Any more questions?
Thank you very much
Super.
for your questions.
Yeah,
This is
appreciate it. Thank
great.
you.
Thank you. Thanks for letting us be here.